Local exam walkthrough series, and we have 2014 problems 1 through 10 lined up. So starting with number 1, basically what you want to do is you want to find each molar mass. So you're finding 4 molar masses, and then for each compound you want to see how much mass is contributed by the magnesium, and then find that ratio to its molar mass, and the highest percentage would win. I'm only going to show D because obviously we know that we're just going to compare percentages and the highest one's going to win. So this will probably be sufficient. So the molar mass of magnesium phosphate is going to be 3 times 24.305 plus 2 times 32.07 plus 8 times 16, which gets us 265.055 grams per mole. That's going to be our denominator when we find this fraction, which is going to be our percentage. And then in the numerator, we're going to have 3 times 24.305, because that's how much mass is contributed by just the magnesiums, times 100% is equal to 27.51%. And obviously that's the highest, so we chose D. For 2, basically what this is we're reacting H2 and N2 to produce ammonia, and the ratio of N2 to H2 is 1 to 3. And for every 1 N2, you're producing 2 ammonias. And if we count up these spheres in the diagram, we're going to count 5 N2s and 12 H2s. So, obviously that's not a precise ratio. It's not the one we want, which is 3 to 1, so there's going to be a limiting reactant that comes into play here, and that would be H2, because 12 over 5 is less than 3 over 1. So H2 is limiting, so we're using 12 of H2, but we're only using 12 over 3 equals 4 of N2, so that means we're making 8 of NH3. So that's why we would choose C. So we have this compound vanillin, and okay, so we have a known mass of vanillin, and we just want to find out how many oxygen atoms are in that known mass. So the first thing we're going to do is convert this mass to a mole value. So 45 milligrams is the same thing as 0.045 grams. And then we're going to divide that by the molar mass, and that's going to get us 2.96 times 10 to the 4th moles, or 10 to the negative 4th, sorry. And we're going to need to multiply this by 3 because there's 3 oxygen atoms per every molecule of vanillin, and that would get us 8.88 times 10 to the negative 4th moles. But this time the moles is qualifying the oxygen atoms, not the moles of vanillin. So we're going to multiply by Avogadro's constant, because we're converting moles to atoms, and we would get 5.348 times 10 to the 20th, which, if you round, is just B. Okay, so 4 was the molarity of sodium ions in a solution prepared by... Okay, so definitely the most common error with this question is going to be forgetting to multiply by 2 to count for the fact that Na2SO4 dissociates into 2Na plus and SO4 2 minus. So we gotta make sure that we're finding the correct molarity. Okay, so basically we start with 0.55 molar and 0.25 liters of it, and that means that we're going to have this many moles of Na2SO4, but we have to multiply this by 2 because for every 1 Na2SO4 that you have in solution, it's going to dissociate into 2 Na pluses. So we actually have this amount of sodium ion. And the final volume is 1.25 liters. So if we do this, that should tell us that our molarity is 0.22 molar and 3 sig figs, so 0.220 m. Okay, solubility of potassium dichromate is that, and okay, so basically We're given a mass to volume, or a weight to volume ratio, I guess that's more accurate to say. That's the maximum solubility at 20 Celsius. So we're basically just going to compare that ratio. So this is the maximum solubility, and these are the conditions that were given. Yeah, so these are the conditions that our solution is, and this is like theoretical maximum dissolved solution. Here, so it's just 6 times 20, so you'd get this. So that's less than 125 grams per liter, so it's unsaturated. If it was 125 exactly, then it would be saturated. If it was more, then it'd be supersaturated. Dilute's just not something that you would choose. Which of the following is a weak electrolyte? That's strong because you have the Na+. That's strong because it's a strong acid. That's strong because you have the K+. This is a weak acid. Not weak in the sense that it's not super acidic. It's pretty acidic, but weak as in it doesn't dissociate 100% in solution. Okay, so number 7, nonmetals that are found in their elemental forms in nature. Okay, so basically, you cross this one out because halogens are too reactive to just be found like chilling by themselves in nature. This is also a halogen. This is also a halogen. So that's why you choose C. 8, which cannot act as an oxidizing agent. Okay, so what to remember for this is that oxidizing agents get reduced, reducing agents get oxidized. So in this case, we need to pick something that can't be an oxidizing agent, so it can't get reduced further. If you remember, reduce, or like reduction, means that you gain electrons, you get more negative. Sulfur can't get more negative than 2 minus. So that's why you would choose A. 9. What is the primary component in stalactites and stalagmites? I don't think this is really like a logic thing. Maybe you could logic it out. I guess like just knowing that carbonates are in a lot of rocks, but pretty much like this is just some common knowledge that you'd have in the back of your mind from, I don't know, reading some textbook or something, or just from like childhood. Okay, so 10. Okay, so I don't know why you would report it like this actually, because I don't know much about statistics at all, but there's a reason that I chose B. You can reason it out to B without knowing why you would include this plus minus thing. So you have all these values to the hundredths place, so your reported value is going to be to the hundredths place because you can't just like manipulate it and turn something else in. So that's why you can just like x, because those aren't to the hundredths place. So that's why I chose B. But if you actually take the exact average, this is what you'll get, 10.074. But the reason you report it as 10.07 plus or minus 0.16, I'm guessing like the 0.16 is some sort of like 90% confidence interval or something. But you'd keep it to 07 instead of 074 because you need to preserve the amount of decimal places because of sig fig rules. For addition and subtraction, that is. Oh, okay, so I'm probably just gonna record the 11 to 20 video like right after this one, but it's gonna be in a separate video, so stay tuned for that. See ya.